Hello. Um, this is going to be the live stream where I try and code the Fate game engine, which is going to be a C++ based game engine. This is inspired from what Casey Muratori is doing with Handmade Hero, but I am not no Casey Muratori, so this is going to be me putting together a bunch of libraries to create something that is close to a game engine. The plan is to make games and add features as required. So let's begin. Let's begin by creating our live stream folder inside the game dev folder. Um, so full disclosure, the Fate engine has had some progress already. You can find it at I'll put the link in the description. You can find the current progress in this repository, but I'd like to get to where I am currently in the actual repository on stream from scratch. So this is going to be our repository. It's called Livestream, and let's create a main.cpp. Yeah. Let's start with a very simple program. Let's start with hello world, of course. Um, uh, yeah. Um, we are going to be using CMake to create our project. We could be writing make files directly, but I've from the limited experience that I've had, I've used CMake makes your project much easier to break into multiple smaller libraries, integrate with other libraries, etc. So you need to have CMake installed, obviously. I have that. If you need CMake, you need to do at least on Ubuntu, you can just do this and you get CMake. You also need a C++ compiler, so I would suggest getting clang or G++. I have both of them. To create a CMake project, essentially you need something called a CMake lists.txt. This is what defines what kind of this is what tells CMake what to do when you want to make a build in your project. So we need to start with telling CMake what version of CMake are we expecting. So I think CMake required, what's it called? Wait, let me go check. CMake minimum. Okay. What is our CMake version? 3.14.6. So let's set minimum to 3.14. The project, I'm gonna copy most of this, is called Fate. Version, let's call it 0.1. Oh, these need to be full capitals. That's how CMake will understand what you're talking about. They don't need to be, but it's just convention. A simple game engine, and we need to tell CMake what languages we are using. If you're using C, we tell it we write C, but if you're using C++, CXX is what we set. Next thing we need to tell CMake is we need to tell it to add a executable. Let's call it main, and we need to tell it what it depends on. So currently it depends on main.cpp, and that's it. Actually, it's going to compile this. If we tell cmake to go make a build, let's go to Livestream. It's nice to put your build files and everything, temporary files, into a build folder. So let's go into build and tell cmake that your cmake list is just outside. Hey, what's wrong? Oh, it's called languages. Cool. And cmake goes and finds all the required executables libraries that this project needs, and then creates a make file. So as you can see, I have set clang to be my default compiler, so that's that. So when I say make, cmake is going to go compile, make is going to go compile main.cpp into an executable called main. Let's see, there it is. So it exists now, and then now we can run it, and we are golden with hello world. Cool, that's our simplest cmake setup. Can I quit this? Yes, let's quit this. What else do we need? So the idea behind Fate is that we're going to follow as closely as possible data-oriented design. You can find details of what that means on this free online book. Most of our state is going to remain outside of as a separate object, and the engine is just going to process the data. We are going to be using a few libraries that let us create windows. So for windows, we're going to be using SDL, windows and input. Oh, nope, wrong SDL. SDL C++ should get us. Where's the SDL library? Homepage. There it is, libSDL. So we're going to use SDL to create windows and parse input from the mouse, keyboard, window events, etc. We are going to use, as I mentioned earlier, I'm no KC Muratori, and I'm not creating a renderer from scratch. So I'm going to use this wonderful library called BGFX, which does cross-platform rendering. And lastly, Entity is a C++ library that lets you implement ECS within whatever you're creating, and that plays very well with the data-oriented design philosophy that we'll try and keep up with. I don't promise that we will be doing it complete justice, but I'm learning as we go along, and I hope you are learning too. Okay, so the first thing we need is some setup in our project. So let's see. Oh, right, let's first, before you do anything, make it a habit to create repositories and commit your shit. So this is Magit. Magit is built in, is one of the plugin packages that Emacs has that lets you interface with Git very easily. So I'm going to just ignore the build folder. Let's do that. Don't need the build folder. I'm going to ignore the CCLS cache. CCLS cache is a folder created by CCLS, which is the completion package that Emacs is using right now. It provides completion functions, etc. So let's ignore this as well. CCLS cache, don't need you, and let's stage all of this. Let's commit, set up basic C++ project, hello world. And let's go create where is it? Let's go create a new repository. Let's do that. Let's create a new. I'm gonna call it Fate Livestream. The live streamed version of Fate. Let's create this repository. And it's very early morning here. Don't mind the birds that are creating a ruckus outside if you can hear them. I've set up my noise thresholds to be very high, so you might not, but if you do, I'm sorry about that. Let's push to master, and we are ready with our online repository. There you go. So right now our CMake list is bigger than our C++ itself, but we can change that. Okay, what do we need? We should be splitting our project into multiple little modules, and let's keep all of our actual code within source, right? And let's see, source is going to have its own CMake, but we'll get there. We can make, so the idea is to split the engine into multiple smaller modules, right? So let's start with the most basic module. Let's create a log module, which does log.cpp, and let's create an include folder. Let's call this fate, and let's call this log.h. So what this lets us do is, I'll show you. Let's just create log.h first quickly. You can define your header boundaries using if and def, but I'm just lazy right now. So let's call this namespace, put everything in the namespace, and log message. I want to use string for this. Okay. Emacs went into C mode, but let's bring it back to C++. So we're going to use log message, and let's define log message. Do you see now why we put even though the include, we put a separate fate folder inside include folder, because then we get to do this, and all our header files look namespaced. So let's do that, and here's what we're going to do. We're going to create another CMake list.txt that is specifically for the log module. Let's call this as 3.14 as well, and we're going to do add library. We're going to call it log, and it's going to depend on, it's going to get out, and that's here, and it's going to go into include fate log.h, and it's also going to depend on log.cpp. I think that's about it. We've set up this library separately, and then we can let's create another CMake list here. I'm just gonna add a fate.cpp just to, it does nothing, it is empty, and it just provides this particular compilation unit something to compile. So three 3.14 and library, let's call it fate, and it depends on fate.cpp, and let's go add subdirectory. This lets us include our log function, library. It becomes visible here, and then we can do target link libraries fate shared. Oh right, we have to define that inside this as well. I think add library shared, and we can just go private. Let's make it public. Private. Now we've linked log to fate, and now fate will have access to all the functions within log. Okay, the next thing we need to do is, we need to give log some include directories, otherwise it will fail. Target include directories log. Let's make it public. We can figure this out as we go along. This gives this adds include. Now log can access all the headers within include. This can do that. Let's link it here as well. Target linking. Target include directories fate like there. Let's get out of here and look at the CMake. We can do add subdirectory source. This exposes fate as a library, and then we can do target link directory is link libraries. We're going to link fate to main, and let's also include this guy. Yeah, that looks all right. Let's see if it works. Oh, we didn't say fate was shared library. I want to keep everything shared. This splits up the libraries and makes compilation a little bit faster. So let's do that. It's going to create, so as you can see, it created a shared library libfate.so and then linked everything to main. Let's go change main. Let's go include fate log.h, and instead of this we go log message. Within fate we go log message hello world. So that's the thing about make, it knows what changed. And oh no, it cannot find log, so I wonder what's wrong. Now I should be able to. there. So what happened was log was added as a private library to Fate, but the functionality within log needs to be exposed within the main, within whatever is integrating Fate. So we made log as a publicly tacked on function to Fate. So everything inside log is now accessible. And let's try and run it. There, this hello world is now getting printed through our logging library. Why have I done this? I have done this so that we can now integrate something like speed log, which is a very good C++ logging library, and include that. So let's use that. Let's do that right now. Let's just clone this. CD source maker lib. So we're gonna keep all our libraries inside libs, and let's clone speedlog. Let's see how can we integrate speedlog with our library. So if we go look for speedlog, that should be good enough. So we have speedlog now. Should be within libs. There you go. And what else do we need? We need to tell log about it. So let's include that only within the logs CMake lists. Let's go add subdirectory. We can get out of here, and it's within libs speedlog. Yeah. When you add a subdirectory that's actually not a subdirectory but it's outside, you need to tell CMake where to put its binary files, where it should compile all the binary files for that particular library. Otherwise, it automatically creates subfolders within your build folder. So what I mean by that is when you look at the build folder here, CMake has automatically created a source folder and it has created a log folder because log was added as a subdirectory to source. But log now needs to add something that's outside, that's one level above. So we need to tell CMake where it's going to put all these speed log files. So let's do that. Let's tell CMake that let's put it in the binary directory and put it inside libs. There, it's going to do that. And I'm going to do target link libraries log private. We don't want to expose speed log at all. Log private speed log. That's what it said, right? We need to do private speed log. Yeah, okay. Let's see if that works. So as you can see, we put a dependence on speed log for log, and speed log has multiple other dependencies which it defines, and it went and found, CMake went and found all of the required things for speed log and wrote the configuration files. Let's see what it does when you try and build it. Now speedlog.cpp will take its time to build because it now needs to link itself to speedlog. Log.cpp will take its time to build because now it goes and needs to build speedlog first and then link it to log. So as you can see, it built a static library speedlog, and then I'm sure during the linking phase of liblog it linked speedlog to log. So here's what we can do now. Where's my log boy? Log.cpp. What this private means is essentially I cannot refer to speedlog in the header file because header file is a publicly exposed interface, but I can refer to speed log here. So let's do that. And how do you use speed log? Let's go see. Need to include this, and then you can do this. Okay, cool. So you need to do that, gives you access to that, and then you can do speedlog.info. So Emacs is throwing up red everywhere. We'll fix that very soon. Let's see what it does. So, interesting. We need to do position independent code for all of this. So I remember I've done this before as well, where I needed to make position independent code. Let's see. I'm sure I can go find it inside. There, CMake can set that up for us. So we just say set CMake position independent code on within the log CMake lists. Linking needs to know where all these functions are, and if it's not position independent, if I'm not creating a static library, setting position independent code becomes important. So that should fix this particular bug. While it's doing that, let me check the live stream. How are things going in the live stream? I have, it's pretty cool. Looks all right. And it's still building. It needs to build speed log again, because now it needs to switch on position independent code before doing anything. If you do main, so much more information, because speed log is now actually displaying this information. This hello world is going through speed log to get to the console. One more thing I wanted to do before ending the stream today. What was that? We need to set up, oh right, so Emacs is going all red everywhere because it can't find all of these things. That's because CCLS needs something called compile commands.json to figure out how the program is structured and where all the completion files are. So let's go and tell we need to tell it to compile this there it is. It's called CMake export compile commands on, and now that will create, actually you can see what that will do. It creates a file called compile commands.json, which we need to link, which we need to tell CCLS that it can find that in the base folder of the project. But it doesn't make sense like to copy compile commands every time. So this is what you're going to do. You're going to link it. You're going to link build compile commands.json to compile commands.json outside. So if you see now outside, there is a link to this, and we're going to tell CCLS to reload, and that should fix some of these bugs. Let's open log or CPP again. Yo, I'm gonna kill all the buffers of Livestream, and let's go inside. Let's restart. There. Now it can find speed log, and all of this works. Now it should be giving me completion lists as well. There you go. So we have set up our project properly. for completion. It's also doing information on the side. This I find annoying, but sometimes not. Sometimes it's very useful. Okay, cool. That's going to be it for the live stream. I'm going to just commit everything. Oh, we need to ignore compile commands. That's going to change almost every build. We're going to stage our source folders. We're going to stage everything. I'm going to do setup first, library, and folder structure. Push. There you go. That's it for the stream. Today, what have we done today? We have set up a simple C++ project. We have also set up our folder structure for how our lib fate is going to look. I'll talk more about how we're going to have what a game engine really needs. I am by no means an expert, and I'm finding these things out as you go along. I have advised against making a game engine many times. There's a video of me telling you not to do it, but this one is all about learning. This is probably never going to be used properly for a game, so this is all about learning how an engine works, and all of us can go on a journey together. All right, bye bye, see you tomorrow.